This is the third video in Unit 1, 1.3, solving equations with variables on both sides. This first step is just a little bit of a reminder of the solving process, and I actually added a few things. So first off, if we have fractions, then make sure that we can multiply everything by the denominator. Next, if parentheses are present, we have to remember to distribute everything, the term that is outside the parentheses to everything inside the parentheses. Next, we're going to simplify each side by combining like terms, move all variables to one side of the equation, then move all constants to the other side of the equation. And we do both of those using inverse operations of adding or subtracting. And then the last is to get the variable all by itself using multiplication or division. Okay, we're going to first take a look at this error analysis. So the student has done this problem and they did one step, but they did it incorrectly. So the best way to do these problems is just to write out the problem as it is and then see what mistakes that they made. So if I write out this problem, dots kind of make it hard to see here. Okay. If I write out this problem and then I want to just not look at the work that they did and see where they messed up. Okay, so first off, since I have parentheses, right, I know that I have to distribute. So I have 0.15 that I need to multiply by the y and the 0 and the negative 0.2. So that gives me 0.15y is minus 0.03. And then on the other side, I have to distribute because I have parentheses. So this negative 0.5, I multiply by the 1 and the negative y. This 2 just stays where it is because it's not directly in front of the parentheses. I'm not doing anything with it. I'm just bringing it down. So negative 0.5 times 1 is a negative 0.5. And then a negative 0.5 times a negative y is a positive 0.5y. So let's see where I have a different answer. Okay, so everything looks the same except for right here. So that is my mistake. So it seems to me that in this original problem that the student multiplied 0.15 times 2 instead of 0.15 times 0.2. Okay, so I would just make sure that when you type stuff into the calculator, that you make sure you're putting the decimals in the correct place and that you are counting the correct amount of zeros. Okay, so we're not really adding many steps. It's the same thing that we've done before, but now we're just adding a little bit more to it. So first off, we can't distribute. We don't have any like terms on the left or the right, but we can have variables that we need to move. So I want to move my variables to the to the left. We're going to add 6k to both sides. Once we do that, negative 3k plus 6k is 3k. Plus 4, we're going to bring down. And then we're also going to bring down this negative 2. Next step is to move constants to the other side. So I'm going to move my constants 4 to the right. Now I am left with just a 3k on the left. Negative 2 minus 4 is a negative 6. And then lastly, I'm dividing off that 3 in front of the k. That leaves me with k equals negative 2. And feel free to pause the video if you need to, if this problem goes too fast or you need to stop and write down stuff. Okay, next example. Now this problem requires distribution. So we have to distribute first. So we're going to distribute the number that is in front of the parentheses, which is a 4, to everything inside of the parentheses. So 4 times 4x, 4 times x is 4x. And then 4 times 9 is 36. And then the other side, there's no distribution. We're just going to write it down. We look at both sides. We don't have any like terms to combine, but we do have variables that we need to move. So remember that there is an invisible 1 in front of this x, in front of any variable that doesn't have a number in front of it. So to move to the other side, I'm going to subtract 1x from both sides. So I have 4 minus 1x is 3x. And then I'm just going to bring this 36 down, as well as the 9. Now my next step is to move constants to the other side. So I'm going to subtract 36 from both sides, leaving me with a 3x on the left and a negative 27 on the right. Last step is to divide off my coefficient, which is a 3. As again, on my left, I have just an x. And then negative 27 divided by 3 is a negative 9. Okay, example 3. Another distribution. So multiplying 5 times 2x and 5 times 6. So 5 times 2x is 10x. 5 times 6 is 30. And then the 8x plus 48, I don't have any distribution, so I'm just going to leave it as it is. Checking for like terms, so I don't have any like terms that are on either side of the equal sign, but I do have variables that I need to move over. So I'm going to move this 8x over to the left by subtracting it from both sides. Once I do that, I get 10x minus 8x is 2x. Then I'm going to bring the 30 down. And I'm also going to bring the 48 down. Now my next step is to move constants to the other side. So since I moved my variables to the left, I'm going to move my constants to the right by subtracting 30 from both sides. 2x comes down over here. The 30s will disappear because they equal 0. Now I have 48 minus 30, which equals 18. And the last step is to divide that coefficient on both sides. Then on the left here, I am left with x. And on the right, 18 divided by 2 equals 9. Okay, on this problem here, we see that we have this t that's by itself. So remember, there is an invisible 1 in front of this t here. Okay, now no distribution because I don't have any parentheses. Don't have any like terms on either side. Next step is just to move variables. Okay, so my variables do need to move to the left. So I have this negative 1t, so I'm going to add 1t to both sides. And make sure that whenever you're adding decimals and whole numbers, that if you do it by hand, that you're lining up the decimals correctly. Okay, so 1 should be placed like in front of the decimal. So say I was going to add it correctly, the 1 would be right here. Okay. But if you're not quite sure, then you can always just make sure that you put into the calculator correctly. So on the left side, I'm going to have 1.25t. And on the left, I'm just going to have 0.25. And then the last step is just to divide off that coefficient in front of the t. So 1.25, I'm going to divide off on both sides there. And then on the left, I'm just left with t. And then once I divide 0.25 divided by 1.25, I get 0.2 as my correct answer. Again, just be careful when you are adding, subtracting, multiplying, and dividing those decimals. Okay, this next example has some double distribution. Okay, so first we're going to start on the left. We're going to distribute this 100 to the z and to the negative 0.2. So 100z is just, if you remember, there is an invisible one here in front of this z. So that gives me just 100z. And then we're calculating 100 times negative 0.2, which gives me a negative 20. And then on the right side here, we have a negative 10 times a 5z, which gives me a negative 50z. And then a negative 10 times a positive 0.8, which gives me a negative 8. So looking at each side, we do not have any like terms. This has a z, this doesn't. This has a z, this doesn't. So no like terms. But we do have variables that we need to move. So this negative 50, I'm going to move it over to the left here. So I'm going to add 50z to both sides. Okay, and then once I do that, 100z plus 50z is 150z. And then I'm bringing down this negative 20 here. And then on the right, I just have a negative 8. And then I need to move my constants to the other side, so I'm going to add 20 to both sides. Again, feel free to stop, and if you feel comfortable, to work out the problems by yourself, and then you can see how I did it. Okay, and then on the left side, we're going to bring down 150z, and then negative 8 plus 20 is a positive 12. Okay, and then the last step is to divide off my coefficient. So I'm dividing off 150 on both sides. And then 150s will cancel out to 1, and then we have z equals 0.08 when I divide 12 by 150. We actually have one more section in this video, and this is special cases. So the problems that we've done so far have been problems where we've only had one solution. Only one value will make the equation true. And it ends with a statement such as, like, x equals 4. So an example would be like when I have this and I subtract 1 from both sides, leaving me with 2x equals negative 4, divide off my 2, and x equals negative 2. So problems like these are the ones that we've been doing so far in class. But there are two other types of solutions that we need to look at: no solutions and infinite solutions. So the first one, no solution. So no value will make the equation true. The variables will zero out, and it ends with a false statement. So let me show you what that means. When the variables zero out, so in this case, the first step I would need to do is to move my variables to one side. So I'm going to add 8x to both to this side and to the left side. But do you see what happens? This is a negative 8 and this is a negative 8. So when I add 8x to both sides, they'll cancel each other out, leaving me with just the constants. So I'm left with negative 4 equals negative 2. Well, that is a false statement. So whenever I have a false statement like this, then my answer is going to be no solution. And just keep in mind that my answer is not a number, and my answer is not false. The actual answer will be no solution. Okay, and the last one are infinite solutions. So in this one, variables also zero out, but it ends with a true statement. So let's look. Again, my first step is to move variables, but I kind of get the same issue that I was having with the no solution. Once I add the 9 next to both sides, they both cancel out. So that leaves me with just a -5 on the left and a -5 on the right. But unlike the other one, this is a true statement. So whenever you get a true statement, there's two possible ways that you can have this that you might see the answer. One is infinite solutions, and then the other one is all real numbers. So you will see either one, and each are valid answers. Okay, this next problem is dealing with a double distribution and variables on both sides. So let's start with the distribution on the left. This 2 I'm going to multiply by the y and by the -6. So 2 times y is 2y. And 2 times -6 is a -12. And then on the other side of the equal sign, this 3 is being distributed because it is the right before the parentheses. So 3 times 3y, so 3 times y, sorry, is 3y. And 3 times -4 is a -12. And the y is not in the parentheses, so we don't have to distribute anything to it. We're just gonna bring it down. Now we're gonna look at like terms. So if I look on this side, I don't have any like terms. This is a y and this is a number. But if I look over here, I have a y, a number, and a y. So these y's, they are like terms. So I'm gonna combine 3y minus y. And if you don't remember, there is an invisible 1 in front of this y here. So that's just like saying 3 minus 1. Okay, so on the left side, I'm just going to bring these down because I don't have any, oh, that's a negative, because I don't have any like terms to combine over there. So I have 3y minus 1y over here, which gives me 2y. And then the -12 in between them, I'm just going to bring down. Okay, so now I have variables that I need to move to the left side. So I'm going to subtract 2y from both sides. Okay, so a weird thing is happening here. So on the left, my 2y's cancel out, leaving me with just the -12. And then on my right, my 2y's cancel out, leaving me with just a -12. So remember from our notes from the previous slide, this is a true statement. -12 does equal -12. So that means that there are infinite solutions to this equation. So you might see it written as infinite solutions or all real numbers. Either are valid. That just means that you can place any value in for y, and it will be a correct value. And lastly, these are just some questions to think about. So how can you recognize when you only have one solution of a problem? How can you recognize no solutions? And then how can you recognize infinite solutions? To kind of help answer those last two questions, when your variables zero out, what should you look at next?